All right, so 1-4. What we're going to do now is we're going to take what we did with function notation and we're going to add on. So let's just do a little bit of review here. So I have a function f of x, I have a function g of x, and I have a function h of x, and they all have different values. So if I want to find f of 2, f tells me I'm using this function. This is going to be g of 2. G means I'm using this function. H, I'm using this function. So it's super important, especially as we get into graphing these, that you're picking the right functions to the right ones. So remember, this is the same as f of x. So when x equals 2, so I plug 2 in for all of the x's. So f of 2 is going to be 5 times 2 plus 2. So 10 plus 2 is 12. Okay? Now I'm going to plug in 2 into my g function. So g of 2 equals 3 times 2 minus 5. So 6 minus 5, so g of 2 equals 1. Now, I didn't write f of 2 here. I should have. That's correct notation, because this would be like saying y equals 12, right? So this is the same thing, all right? So now h, that's this function. So h of 2, I have 3 times 2 squared. This is the same as 3 times 4. Remember, I do exponents first. And so h of 2 equals 12. Okay, now what we're going to do is we're going to go into this concept of composite functions. And a composite function means we're going to take one function and put it on the inside of the other function. So this is the best way to look at this. Now, what we want to do, I'm going to show you two different things here, is this is just saying that we have a function in a function. So g of x is my function inside of the function f of x. And so what we would do is we would read this as f of g of x. So this little circle that we have there is not multiplication. This circle is another of. So f of g of x. So we have g of x on the inside. So f of g of x. So what makes this difficult is what's on the outside versus what's on the inside. So I'm going to rewrite this function as f of g of x. I think it's a whole lot easier to look at it this way. Okay? Now, this f, this is my outside function. And this g that I have right here, this is my inside function. Now, you always want to do the inside function first. Now, because this is just an x, nothing's going to change. My g of x function is this, 3x minus 5. So nothing, so g of x right here, I'm just going to say g of x equals 3x minus 5. Now, if this was g of 2, then this whole thing is going to be 1 because I would do the inside first, and we just did that and we said that it was 1. But because there's not a number here, there's going to be an x in my answer. So g of x equals this. So then I have to go to the outside, and the outside is this blue. So I go to my f function, and my f function says 5 parentheses plus 2. Now, if you think about what we did here, we said anywhere there's an x in the function, we plug in a 2. Well, now, here's my x in my function, 5 times x, but instead of plugging in a 2, I'm plugging in my g of x. So this is what goes on the inside, 3x minus 2. Okay, make sure you pause the video and look and see if you can follow all of this, if I'm going too fast. So real quick, f of x, we're saying f of 2, I plug 2 in and I get this. So all I did was I took 2, everywhere there was an x, I plug it in. Well, now I've got my f function, which is still the same thing, 5 parentheses plus 2, but this time what goes on the inside is the g of x function, and this is the g of x function, so I plug it in. Okay, so now I do the math. So I have f of g of x, and that's going to be, I'm going to distribute, so 15x minus 10 plus 2. Oh, hold on. What in the world? I knew I made a mistake. This should be 3x minus 5. I'm sorry, y'all. This is 3x minus 5. So this should not be 10. This should be 25. Yikes. So 3x minus 5. If you were wondering where this 2 came from, that is a total typo on my part. It should be 3x minus 5. All right, so now, sorry about that. I have f of g of x, and this is going to be 15x minus 23. That's my final answer. Okay, now what we have is g is going to be my outside, and f is going to be my inside. It's inside the parentheses. It's my inside function. So my inside function, let's see if I can write this down right this time, is 5x plus 2. That's my f of x function. So I'm going to go over here to my g, and I'm going to have 3. There's where my x is, so I put parentheses, minus 5. Now what goes inside is the f, which is 5x plus 2. So when I do the math on this, I get 15x plus 6, because I'm going to distribute to both of those, minus 5. So g of f of x is going to be 15x plus 1. All right. Now, with this one, it's got this circle notation, so I'm going to rewrite it as f of h of x. And this is my outside, and this is my inside. So h of x is 3x squared. So if I go do my f function, that's my outside, I'm going to have 5 parentheses plus 2. Right? So then what goes on the inside is my h of x. So f of h of x is going to be 15x squared plus 2. Okay. If you were not following me on this, I want you to rewind the video and go back and look at it again and see if you can follow it, because it's about to get a little more challenging. So now what happens is the x's are gone and I have numbers. So if I have numbers like this, there'll be no x in the solution. My final answer will not have an x in it. So first thing I'm going to do is rewrite this. F of g of 2. All right, so let's look at the difference here. This was f of g of x. This is f of g of 2. So we're going to do the inside first. And what I'm looking for on the inside now is g of 2. So I'm going to go back to my g of x function. And this is going to be 3 times 2 minus 5. I took my g of x function, because I'm dealing with g, and I plug in 2, and I get g of 2 equals 1. Now technically we already did that. We did this right here, right? But I just want to show you where this comes from. So now the inside's all done. And so instead of typing in a function now, I'm going to plug this in. So now really what I'm looking for is f of 1. When I solve g of 2, all of this I get 1. So now I'm going to plug in 1, substitute 1 in here, and I get f of 1. So now if I go to my f function, which is 5 times 1 plus 2. So I go back to my f of x function, and I plug it in, and I get f of 1 equals 7. So final answer here, f of g of 2 equals 7. Okay, so g is my outside, f of 1 is my inside. So first thing I have to do is evaluate the inside. So f of 1, so I go back to my function, 5 times 1 plus 2, f of 1 equals 7. We just figured that out down here. We just did that. That's okay. So now I go to my outside. So my outside is going to be my g function. So I'm going to have 3 times 7 minus 5. And this actually is g of 7. It's my g function evaluated when it equals 7, because f of 1 equals 7. So g of f of 1 is going to be 21 minus 5, which is 16. Okay, I'm going to pause the video. You're going to need a calculator on this next one, but go ahead and do this next one and then come back and see if you did it right. Okay. First we evaluate h of 4, so make sure you pick your h. Do the math, you get 48. And then we take 48, which is the inside, and plug it into the outside. So f of 48, when we plug that in, I used my calculator on this, I got 242. Okay? All right, let's plug this over and let's do this with some graphs. And I'm going to do two things here. I'm going to use a highlighter because I think it's going to be easier, and I'm going to highlight my two graphs. So my first graph is g of x, and that's this one. It's going to be this yellow highlighter. And I think it's going to help me to not be confused between the two. Hold on, I'm grabbing another one here. Okay, I highlighted my other one in green. Okay, now we're going to do exactly the same thing that we did, but we're going to pull numbers off of a graph instead of doing it algebraically. Over here, we did it all with algebra. Here, we're going to use the graph. Now, this is not a circle. This is a plus sign. So we have an addition sign, not a circle. So because of that, I'm going to rewrite this. And really what this is saying is f of negative 1 plus g of negative 1. This is not a composite function. So the only time you're going to see a composite function is if you see a circle or if it's written this way, f of g of x. Okay? This is just saying take the f graph at negative 1 and find the y value. Take the g graph when x equals negative 1 and find the y value. So we can rewrite it like this. It makes a lot of sense. So the f graph is my green graph, and the g graph is my yellow graph. So if I look up here and I want to know f of negative 1, I'm going to go to negative 1 and I'm going to go to the green graph. And I see that that value, the y value, is negative 2. Now I'm going to go to negative 1 on my yellow graph, which is my g graph, and I get this value here of 1. So negative 2 plus this value is 1. So the whole thing equals negative 1. Okay, now this, be careful. This is multiply, not a circle. This is not a composite function. I'm just going to multiply this. So what I have is f of 4 times g of 4. Same way we did this. We're going to find the values, but this time we're going to multiply. So what is y when x equals 4 on my f graph? F is my green graph. So I go over here to 4, I go up to my green graph, and I see that that value is 3. And then I go to my g graph, and I go to 4, which is my yellow graph, and that's 1. So 3 times 1 is 3. Okay? Now, based on what we just did, I want you to work letter C. So I'll work it too, but I'm going to pause it, try it on your own, and come back. Okay, so I'm subtracting. So this means I subtract. The value here is the same for both of them. This is where, this is where it intersects right here. So I end up with negative 1 minus negative 1. So negative is positive. So negative 1 plus 1 is 0. Okay, so here I have a composite graph. So same thing I did before. This is my outside, and this is my inside. Okay, so I have to do my inside first. So I want to know what is the value of g of 6. So g is my yellow graph. So I go over here. When x equals 6, g, the y value of that is going to be negative 1. Okay, so then I go to my outside. So what I'm looking for now is f of negative 1. So all of this simplifies to negative 1. So I have f of negative 1. And remember, this is f of x. So when x equals negative 1, so I'm going to go over here to negative 1, I want to know the f graph, which is my green graph, and that value when f equals negative 1 is negative 2. Okay, a couple more. So let me rewrite this one. This is a circle, so this is a composite graph. So I have g of f of 4. So this is on the outside, g of f of 4. So I'm going to do the inside first, and I want to know what is the value of f of 4. So I go over here, f is my green graph, I go to 4, I come up here, and I get the value of 3. So this value is 3. So now I go to the outside, and I want to know g of 3. So when x equals 3, g is my yellow graph, and that value is 2. Okay, now this is kind of fun. So this tells me that g is my outside graph and g is my inside graph. So remember, we always go from inside out. So g is my yellow graph. So if I want to know this part, g of 0, I go over here. G of 0 is going to be 3, right? That's my yellow graph. When x equals 0, that's my y-axis. So this value is 3. Now, what I just did is I solved for the inside. So now I have to take this value and plug it in. So now I want to know what is g of 3. So I'm just using the same graph. So I go over here to 3. It's still the yellow graph. And I go up here, and that happens at 2. And that's my final answer. Okay, these get a little bit tricky, so make sure you're following along with this. Okay, thanks.